0. The square root of x plus 5 minus root 5 over x. Okay. And then let's just verify that when we plug in 0, we get an undefined or improper form. So if I put 0 here, I'd have square root of 5. Square root of 5 minus 5 is 0. 0 over 0 is 0. And then that also tells us that we probably can remove it. So now we're going to do rationalizing. Okay. Tell me, you guys tell me, what should I multiply by? So when we're doing rationalizing, you leave the square root part the same. I see where that's confusing because there's several signs, but what's under the square root is going to be identical. This is the one that changes. So then we would write plus root 5, and we do it on top and bottom. When we multiply out the product of these two things, come on, focus. Product of these two things is just going to make that square root go away, so it's just going to be x plus 5. We know, because really I then have first, outside, inside, last. So outers and inners I'm not going to bother writing down because they are going to cancel their exact same, opposite signs. Minus root 5 times positive root 5 would be minus 5, because root 5 times root 5 is root 25, which is 5. On the bottom, I am not going to write this out because it's not going, the rationalizing part we do for getting rid of the tops radicals, it's not going to make anything prettier in the bottom. So I'm going to just leave it. Do you see how this cancels then? Plus 5 minus 5. Also, do you see that I have just x on the top and I have a factor of x on the bottom? So this is going to reduce to 1 over the square root of x plus 5 plus root 5. And that's all on the bottom. Now we should be able to evaluate the limit as x goes to 0. So we do. So we put in 0 here, and we have 1 over root 5 plus root 5. I'm going to just write that as 1 over 2 root 5. And you can leave it like that. You don't have to worry about rationalizing it. Okay. Are there questions on what I did? Dylan, did you find your mistake? You had?
I got that.
Oh, you did? Okay, so the back of the book rationalized it probably. Okay, so great. I'm glad you got to it. So the way that we rationalize things, and like I said, for me, on a test or whatever, I don't really care. If you have radicals on the bottom on the AP exam, they probably will rationalize it. So we just multiply by the radical to get rid of it on top and bottom. So we'd have root 5. And then now we have 2 times, this becomes 5, which is 10. Is that what they had in the back? Okay. So good. So you had the correct answer. You just didn't rationalize the bottom. Okay. What else? Okay. Oh, 37 is a great question. That's an AP-like kind of question. Okay, I'll just move it up a little. So the question is, if you don't have an equation, how do you evaluate these limits? And limits are instinctual. So what you think you can do with limits. It doesn't work like that with a lot of things in calculus, but if the limit as x goes to c of f of x is 3, then a would just be 5 times that limit, which would be 15. And b, the limit of f of x plus the limit of g of x. So it really would be 3 plus 2 or 5. For c, the limit of f of x times the limit of g of x. So that would be 3 times 2 or 6. And for d, 3 divided by 2 or 3/2. Okay. Yeah. For some reason, the delta x's are weird. They look weird. We've never seen them before, right? They're just treat them like you would a variable. So in physics right now, you might have seen some deltas already, have you? And what does delta mean in physics? That's a good question. It's just the change in x. So typically, like between maybe 2 points, it's like the x2 minus x1. If there's 2 points, it's the change in x. So really what we're doing right now is we're laying the groundwork for next chapter when we start getting to calculus. And because calculus, what we do is we basically take 2 points and we get so stinking close that we're going to say it's 1 point. But it's not really 1 point because you can't find the slope of something when you're dividing by 0, right? So we use this limit to do that. So they're really just introducing you and getting you familiarized with delta x. But we're going to treat delta x like it's just a different variable. It's not x, but I'm going to just see if I can distribute and get rid of it. Okay, so this was the problem. So delta x, pretend it's something else. Pretend it's a y. If this were y, and I try to do 0 and 0, I get 2. If this were 0 and that were 0, I'd get 2x minus 2x, which is 0, over 0. I'd get an indeterminate form again. So let's see if we can remove it. So we got 2x, 2 times delta x minus 2x over delta x. These cancel. So I have 2 delta x over delta x. I don't even have to evaluate. There's no delta x to put in anymore. They both cancel. The limit of that would be 2. Okay. What else? Okay. For 65, I'm going to write down first that one limit that I wanted you, well, there were 2 I want you to memorize, but the sine x over x is the one you're going to see the most. So I'm going to just recall that from our notes yesterday, that if you see x goes to 0, sine x over x, that's a 1. Uh-oh, somebody's going really fast. So let's see what the question asks. What's the limit as x goes to 0 of sine x over 5x. So what I'm going to do is I'm going to pull a 1/5 out to the front. That's like 1/5. You can pull it out to the front of the whole thing of the limit as x goes to 0 of sine x over x. And we now know this part is 1, right? So 1/5 times 1 would just be 1/5. Let's see. 73 is the limit as x goes to pi halves So first of all, I'm going to just show you why this is 0 over 0. Going back unit circle, and think, you know, like really in my pre-calculus class, I really emphasize the unit circle a lot. And so, because I know that it becomes so important. So when I was talking about yesterday, like, hey, virtual pre-calculus, I don't know what was emphasized there. I don't know how much the unit circle was emphasized. But knowing those exact values is a big deal. And it's not hard. It's just that it's going to have to be an adjustment that you make. Pi halves is at the top. And the cosine is 0 up there. So if I plugged in pi halves, well, the cosine of pi halves is 0. Cotangent is cosine divided by sine. So cosine divided by sine would also be 0. So we have an indeterminate form. So it's possible now that I can remove this. All right, so here's what I'm going to do. I am going to, anytime I want to simplify and I see like cotangent or tangent, I want to try to rewrite it. So remember how I said it's cosine over sine? Okay. I think you could probably see what's happening. I'm going to take that, because I got two fractions. It was the top, and then this is like a big division bar, okay? So when we divide fractions, we take the numerator and we multiply by the reciprocal of the denominator. Okay. What happens now? The cosines cancel. And it's not sine x over x, but we can plug the pi halves in and get a value. The sine of pi halves is 1. So the sine of pi halves is 1. The limit is going to be 1, even though it's undefined there. Okay. Okay, how are we doing? There are any other ones you wanted me to do? Okay.
Can you do 41 to be part of the confused on as to write a simpler function that agrees with the different functions?
Yep. Okay. So when we talked about this earlier. When we have something where we get 0 over 0, what that means is that you can divide it out somehow, the 0. And also, if I gave you x squared minus x over x, and I said, what does that look like? And I didn't give you a calculator to graph it, you probably wouldn't know. But you know this is a line, right? Okay. So the reality is, to get the equation of this line, what I can actually do is just divide that function. Like, do x squared minus x over x, as long as we understand that x isn't defined at 0. So we're going to remove it, but in the original function, we're going to just say x cannot be 0. Okay, so don't kill cats. As long as it's just a single factor of x on the bottom, we can do it. The problem would be in, like, look at my little sign there. If there's a sum on the bottom, you can't just divide by one thing. But if it's a sum on the top, I can. So this is x squared divided by x and x divided by x. So x squared divided by x is x, and then I have minus 1. So this is a line, and if you look at the graph, that makes sense. The y-intercept is 1, the slope is 1. But then we would just say that this is true for x, all real numbers, but not x equals 0. So x equals 0 is just undefined. And I don't even know how the back wrote that, but I will check. What was this one? 41? Go. Oh, yeah. They wrote along whatever. Yeah, f of x equals x minus 1, except at x equals 0. Which one? Oh, yes, I can. So squeeze. And I didn't really do any examples with squeeze theorem yesterday except to show you a picture. But I don't know what the function is, but you're told that the function is between these. Okay. So in other words, f on its I don't know exactly, well, I do. 4 minus x squared is a parabola opening down, bumped up 4. 1, 2, 3, 4. And this function, you don't have to know a picture of the graph to say it, but, and then f of x, I know they're the same width, just ignore that part of it. F of x is always staying in between these values, okay? It's always going to be between them. So the question was, can you use squeeze theorem to find the limit as x goes to c is 0? So can you find the limit as x goes to 0? And I can. All you have to do is plug in 0 and here to understand that these both have a limit of 4, right? So if f of x stays in between them, it is also going to have a limit of 4.